Let's also talk about relational operators, which compare values. So once again, I'll just move this down as something we already talked about. So relational operators. And let's just do something very simple. 0 equals to 0, and 1 equals 0 plus 1. Okay, so just an example of two variables being declared. And then we will use an if statement and say, okay, if 1 is greater than 0, which should be pretty much the expected thing, let's just print it's all trivial. Of course, we expect that 1 like this is greater than 0. Okay, so it will print, hopefully will print everything nicely and predictable, and new line at the end. All right, let's build and run it very quickly. Okay, so 1 is greater than 0. You can see that the idea is extremely straightforward. You can check for less than, greater than, equal, and so forth. I'll just show you very quickly what they are. So if I want to say equal, we can do it this way. If I want to say not equal, you use an exclamation point. If you want to display greater or equal, you do it this way. Less, equal is this way. All right. So these are all examples of relational operators. The only thing that kind of strange a little bit is that sometimes you want to check the condition and find out whether it's true or false, and then end up with the desire to flip the result. And so essentially the alternative to existing Boolean result is to use an exclamation point. In fact, we can find its real name right here. It's called logical not, right? So exclamation point expression, and that's exactly what we have. So I would say that the way to rephrase it, perhaps we can say, so I mean, let's just stick with this if statement. I would just say this should not print, right? Because we want to change the outcome. So if I build this, and I'm really glad that the compiler gives us this warning that something is wrong. First of all, let's run it anyways. You see that it's not printing anything, but the idea is that this logical not operator, which we just found in this table, is a unary operator. And if we compare its precedence with the greater than, which is, where is it? On this list, right here. So comparison less than has a lower precedence, and this has higher precedence, the logical not. So what it does, it basically flips this result. It just applies to its operand. It thinks that this is the operand. So if this is what you want, it's one thing. But if you want to apply it to the entire expression, you have to parenthesize. This is really something that you should really remember. Okay, so my idea was not to play with one of the values. My idea was to just check the entire condition, and then based on whether it's true or false, flip the result. So true becomes false and false becomes true. So here, if this works correctly, so if this is not the case, I can just say else, and we could say that just print this and say that Okay, so just, it's in this Boolean expressions is just a little hard to annotate, but even for debugging purposes. So let's just try it. Okay, so it says that not 1 greater than 0 is not true. Okay, so 1 greater than 0 is true, but this flips the result from true to false, because this is not this. It becomes false, which is not true. Okay, so this is how it works. Just remember, once again, it's easy to make this mistake. You're thinking about this entire condition and you want to just flip the result. So instead of doing this, remember to parenthesize, and this is why compiler gave us a warning about it. Right? So I'll switch to something like that. Of course, I would recommend that you tweak this code and play with this code a little bit more, just to find out if every time you make a change, it runs the way you expect it to run. Just a reminder that the if statement uses the condition, and if condition is true, this statement will execute. This statement will be ignored. Else, if condition is false right here, then else kicks in and this statement will execute, and this statement will be entirely skipped, not used at all, not invoked. Only the else part will work. So just pretty simple idea, just to check the condition and decide what you want to do. The else part, of course, is optional, right? It doesn't have to be here, but if you want, you can do it. You can have an alternative to the true outcome of this, to use an else part of the if statement. Something else I would like to show you is this. If I want to check if, for example, 1 does not equal 0, something like this, so I know that my variable is being set to something non-zero, I'm aware of it, and I just want to make sure that it's the case, we can say that out one is non-zero. I don't know what it is, but it does not equal to 0. Okay, and I'll just use new line and print it. In the second case, I will compare 1 with the 0, like this, right? Just in one case, it's not a 0, in other case is a 0. 1 is 0, like this. So I will run it. And of course, it works pretty well. It says 1, right here it prints the value of this variable. 1 is non-zero. So everything is okay. And 1 equals 0 is false, so this never got printed. Okay, so that's fine. And I'd like to tell you that this is the way you would normally write this code in Java, but in C++, normally any integer value, any integral expression that you have, if it's a non-zero, it automatically evaluates itself to true. So my advice would be to, instead of writing it like this, just whenever you compare something with the 0, that's the case, you don't have to do this. Just simply say if this, and look, if it's non-zero, it will become true. Even if it's a negative number, if 1 is set to -100, so this variable equals -100, it will evaluate to true, and so it will print the result. Okay, and likewise, when you are comparing 1 with the 0, instead of doing this, I would advise you to do something like this. If not 1, okay, so any non-zero becomes true, and if you flip it, you get a 0. So in other words, if 1 is set to 0, it becomes false, and not false is true, so it will say 1 and 0. So I'll just to make sure that we can see it, I will say 1 equals 0 right here to force this. I know that the name of the variable is not very nice for this type of manipulation, but I'll just do it for the demonstration's sake, right? Just to make sure that we get all of our printouts. Okay, so here, right, first we say, like before, 1 is non-zero, because yes, it's non-zero to begin with, it's 0 plus 1, and then we force it to become 0, which is horrible choice for coding here and naming our variables, but it becomes 0, and if not 1 now prints that 0 is 0, because instead of saying 1, I'm printing the actual value of that variable. Just wanted to show you that, just remember that any non-zero is true when we're talking about checking conditions with integers, and likewise only a 0 is false, and then we can say that it's a 0. Okay, so these are just some cryptic little tiny details about very, very simple things, and some of it is about the syntax, but that's the topic of today. Operators, looking at specific values, what to avoid and what to remember.